All right, welcome back, everybody. Since we didn't get to R4 and R5 last week because I spared you from something you would not have enjoyed. We gotta do it today. I put a week extension on that assignment. But we're gonna try to catch up. So like I'm gonna do R4 and R5 today. We were originally scheduled to do R6 today. We're gonna do that on Thursday. And we were scheduled to do R7 and 9.1 on Thursday. And I'm gonna make a video for that and post it on Thursday with it, so you guys can watch over the weekend. And I'll give an extra week on top of that one, and hopefully, like, between those, we'll get caught up. Because we need to get shit done, and it sucks that I had to miss a day, but you, trust me, it was for the best. We are still in the review chapter. So it's presumed that you know or have seen all of this before, and we're refreshing it. But if it's been a while, I want to point out some stuff that'll be helpful for you. So in the modules, if you go and look for where our textbook is, it's the johnblakely.com/textbook. It's also linked in the syllabus. You're doing chapter R right here. R4 today, we are going to blitz through factoring. We're going to do a little bit more further topics in factoring in R7. So we'll do a little bit more there, but it's not a whole lot of time to review factoring. If you're looking at it going, this shit, I know like some of it rings a bell, but I want to look further. Come up here and check out his other section, like all of chapter 4 is on factoring. So like, you can come up here and he actually gives pretty good, like he types out in words, like not like the lame math textbook version, but like how you would say it to a student. Gives some rules and then gives examples and shows like working out the examples. Here he's doing a guess and check method, which is terrible. I'm not going to do a guess and check method. I'll show you another method today as part of our speed run. But that's chapter 4. On Thursday, we're doing radicals, the good old square root sign and shit like that, and how it relates to exponents. And that is like a long fucking section. And there's an entire chapter related to that. We're going to spend 2 hours on it, but if you need more review, chapter 8 is all on radicals and it goes into more detail. And then, of course, there's always office hours or the tutoring center to get caught up. I did figure out that a lot of people were going to the math lab for tutoring when I was going to do office hours from 5 to 6. So I have changed my office hours to try to be more assistant to you guys. Let's see. It's in the syllabus, and I think I put it on the actual page on notes too. So I was doing Tuesdays and Thursdays from 5 to 6. I'm still going to do Thursdays 5 to 6 because the math lab's not open on here on Thursday with people from that time, I believe. But instead of sitting in my office from 5 to 6 and no one ever shows up, I'm going to do it from 8:15 to 9:15 tonight on Zoom. So if you're like working on stuff from homework or from last week or from today, and you want to pop in and ask a question, I'm probably gonna be sitting there watching TV with my wife with the screen right in front of me, and I'll just tell her to stop that shit while if someone, and if I need to spend more time with a student, I'll just take the laptop with her. And a link to the Zoom room is right here. So you can always hop in there real quick. All right, so back to what we're doing today. So math 35. This is lecture day 3. R4 is on polynomials, and the biggest section in this thing is factoring. And R5 is on, what is R5? Rational. Rational expressions. Which kind of builds on polynomials, but goes like hard bit. So polynomials. Three x to the fourth plus 5x squared plus 6x cubed minus 7x plus 1 is a polynomial. Polynomials, exponents are positive. And whole numbers. Coefficients can be anything. I can have square root of 3 times x to the fourth, and that's a valid polynomial. Poly just means many. This is where we had monomials, binomials, trinomials, and then they didn't have quadrinomials. They just said, fuck it, we're gonna stop with 3 and we're gonna go with polynomials. Binomials and trinomials is very much like bicycle and tricycle, 2-wheel, 3-wheel, 2 terms or 3 terms. Polynomials tends to be 4 more terms. We tend to write them in decreasing order by exponent, which I did not do here. So I'm going to rearrange it. The x to the fourth was in the right spot, but 6x cubed has a higher exponent than 5x squared. When we add or subtract, we do it with like terms. Like terms have the same variable with the same exponent. If I wanted to, I could instead line these up underneath the same polynomials or same term, same variable, same exponent kind of thing, and add them vertically. 5 plus 7 is 12. 12x squared. 3x minus 2x is 1x. And 2 minus 1 is 1. If we have a variable and there's a coefficient of 1, we generally don't write it. But if there's no variable, you have to kind of put the 1, because there's nothing else there. We also don't show exponents of 1. X to the first is the same thing as x. We don't show exponents of 1. Or coefficients equal to 1. Coefficients are the numbers in front. Coefficients are these things. And it's the same problem. We actually do this in English language or most languages. I never would say I drove 1 car to work. No shit. You didn't have the option. I didn't have the option for something else. We would say I drove a car to work or I drove my car to work. But we eliminate numbers when it's singular. I ate a candy bar. It kind of implies there's only 1. right? Same idea in mathematics. Subtraction works the same way. But you gotta remember to subtract everything in the second group. I'm gonna do the same thing and just change those symbols. One way to do this is if you stack them vertically, switch this to a plus by distributing the negative to everything inside. So negative times positive 7x squared is negative 7x squared. Negative times negative 2x is positive 2x. And negative times positive 1 is negative 1. That should have been, change it, oh well, fuck it. It's not the same problem as above. But either way, the idea applies correctly. Now we can add 5 and negative 7 is negative 2. 3 plus 2 is 5. And 2 minus 1 is 1. They don't have to be friendly. The homework should be throwing shit at you that's complicated. That will subtract . When you got a bunch of shit like this going on, I don't know that stacking them is the easiest thing to do. So. A pro tip when you're tackling something like this, especially if you've got it written out or you can write on your screen like with a tablet or something like that. Go through the first one and look for anything that matches in the second group. So 4x squared y cubed. I'm looking for an x squared y cubed and I have that here. So I've got 4 and a negative 3 gives me a positive 1 x squared y cubed. Then I'm going to do the next one. I'm looking for an xy to the 5th. I have another xy to the 5th here. And don't forget this negative sign. It might be better to distribute the negative right away just by writing over the old symbols with the opposite sign. So here, instead of subtracting negative 4, I'm going to add positive 4. 3 plus 4 is 7. I have plus 7xy to the 5th. So variables and exponents have to match for everything. Combine them. This is x squared y squared, and there is no other one. So there's nothing to combine with that one. And that leaves this bad boy dangling that we still need to address. Negative and a negative made a positive, which we wrote there. So plus 5x cubed y squared. Yeah,
For the one x squared 3q, we don't have to write the one, correct?
correct.
Okay.
We don't need the one, so I'm gonna cross it off. But I wanted to make sure everyone saw what I was getting. If at some point something doesn't make sense, or if it looks like I added something wrong, say something. Like, 2 + 3 is not 8. And if I say 2 + 3 = 8, call me on my bullshit. I may lie and say I was just testing you. That's very rarely the case. Oh, I'm trying to turn the page. I'm at the top of the page. Okay, that's adding and subtracting. We also have multiplying polynomials. When you have a binomial, this is a binomial, there's two terms. Terms are separated by plus or minus. I think we said that before. You probably heard of the FOIL. I don't know that that's helpful. It's only helpful for binomials. The real thing you want to do is just start with one thing in the first parentheses and multiply it by everything else in the second parentheses. So I'm going to do this. I'm actually going to spell out here. I got 3x times 5x plus 3x times -1. Then I'm going to do the same thing with the 2. 2 will hit the 5x. And then the 2 will hit the -1. And that is the last time I will write out the full line like that. So 3 times 5 is 15. And x times x is x squared. Then we have 3x times -1 is -3x. 2 times 5x is 10x. And 2 times -1 is -2. These are like terms, so we're going to combine them together. And our final answer would be 15x squared plus 7x minus 2. What? Yeah. No, that's me being described. Negative signs, minus signs are the easiest thing to fuck up in this entire class. More mistakes are made with negative signs than fucking anything else. From here on through all the fucking courses you will ever take in mathematics, no matter how far down the rabbit hole you go. They're the easiest to do, they're the easiest to miss when you're checking, and they can make you feel like you're a fucking moron. Because you'll know the answer and you'll go, that's not it. What the fuck? I don't understand what I'm doing. Go back and always check your work. That's how we multiply. Let's kick it up a notch. This is called a quadratic. When x squared is the highest term. Highest exponent. I put an A because it doesn't matter what the coefficient is. And I have no idea why they call it quadratic. Quad means 4. And I don't know, maybe because you can factor it and make 4 terms. I don't know. I have no idea. When x is to the first power, they call it linear, and that's because when you graph it, it makes a fucking line. And linear's got the word line right in it, but there's no quad thing in this thing when I grab it. I don't know what the fuck that means. But hey, I don't need to know. All right, let's kick it up. 3x squared minus 2x plus 7 times 4x squared plus 3x minus 2. Now, when you got a bunch, I recommend being strategic. And when you're writing them out, stack shit that's alike. So stack shit, as you'll see me do right now. So I'm going to do the 3x squared first times all of them. 3x squared times 4x squared. 3 times 4 is 12. And x squared times x squared is 4. X to the 4th. And then I got to hit the next one. 3x squared times 3x. 3 times 3 is 9. And x squared times x is x cubed. And finally, 3x squared times -2 is -6x squared. Then I'll do the -2x. -2x times 4x squared is going to give me a -8x cubed. And I'm going to line that up underneath my x cubes. -2x times 3x is -6x squared. I have my x squared right here. I'll line that up underneath that. And finally, -2x times -2 is plus 4x. I don't have anything to line it up for, so I'll make another row, column. This column stuff you don't have to do, you can write it side by side. But making sure you combine all the right things can be a pain in the ass. Now, step 3, I'll do the 7. 7 times 4x squared is 28x squared. My x squared is right here. I'm going to put it right there. 7 times 3x is 21x. I will put that under my x's right here. And 7 times -2 is -14. Finally, add that shit vertically. Nine minus 8 is 1, so 12x to the 4th plus x cubed. 28 minus 6 is 22. 22 minus another 6 is 16. X squared. 21 plus 4 is 25. Right. Eventually, we'll learn how to go the other way. Well, maybe not with quadratics like this, but if these factored, if we had a bunch of binomials like this, we had like 4 of these, we'd still end up with an x to the 4th, and we'll develop techniques to break down this and do like a bunch of binomials. That's way later though. That's like the real good stuff. Any questions? If you don't stack them, you kind of got to go through and make sure underline them as you use them and then make sure everything's underlined or something. It's really easy to fuck up. In grad school, we had this on the fucking worst level where it was like writing, even just writing left to right, line by line. Having fucking like 4 or 5 lines of shit. And trying to match everything up. I'm fucking double underlining, doing squiggly bolts, doing fucking lightning bolts, circling shit. I eventually figured out stack the shit while writing it if you can. It may take up more paper vertically, but. Alright. When we divide polynomials. That's where we get rational expressions, and that is R5. We're gonna do that in a little bit. So we'll skip dividing for now. Next thing we're gonna do is looking at factoring polynomials. Rules of the game. If you can, factor out the GCF first. And GCF is greatest common factor. Step B. Once the greatest common factor is out, we're going to check to see if it factors further. We do that by counting the terms. If we have 4 terms, we're going to factor by grouping. Three terms is trinomial factoring. You'll often see it look like something like this. That's the easiest form. And then 2 terms, we had a bunch of special formulas. Special binomial formulas. Difference of squares. If you walked in at the end of the last class, you saw me doing this. A squared minus b squared will factor into a minus b and a plus b. Or you can do the a plus b first. Because 2 things multiply together, doesn't matter what order you multiply them. Then we have the sum and difference of cubes. The formulas look similar. So similar, in fact, that I'm going to write them at the same time. Both things start off with a parentheses and an A and a B in it. And deliberately leaving some room to put some signs in. But the stuff in blue on the screen is consistent with each formula. Then, whatever sign is in this goes in here. And in the other one, we do the opposite. That's the only difference between the two formulas. The sum of squares. A squared b plus b squared. Factors into complex solutions. And we're not ready to cover that, so that's later. We haven't covered complex numbers yet. There was lots of ways to do trinomial factoring. There's a diamond method, there's all sorts of shit. The quadratic formula, if it's written in the right form, will work. We're gonna try ones that are not the traditional, like shit you would do in beginning algebra class. So we're gonna start off. We're just gonna go straight to the clusterfuck. Should be able to. Okay, so this could be a pain in the ass to figure out the factors of. But we're looking for the greatest common factor first. A good idea is to factor it. I'm gonna make a little table. I'm gonna do all the coefficients first. 30 is 5 times 6. And 6 is 5 times, or 2 times 3. So 30 is 5 times 2 times 3. I'm going to line up similar factors under, if they're the same number, put them underneath it. 39 is 3 times 13. I've got a column for 3s, I'll line the 3 up underneath it. 13 means a new column. And 9 is 3 times 3. I got a column for 1 3. I need another column for another 3. Then I'm gonna go with the x's and go with the smallest exponent first. 9x has an exponent of 1, so this has an x, which means these all have an x. And this one has an extra x, and this one has an extra x squared. And this is where I stop stacking columns because it gets a little tedious, but at least do the first column stat. And then y's, this has a y squared. That's the lowest exponent, so they all have a y squared. This has an extra y and that has an extra y squared. This table is probably new to you. But the greatest common factor is 1 from each completed column. Completely filled columns are the 3, the x, and the y squared. So the GCF is 3xy squared. Then what I have left over is, if you've done the table, everything that isn't in a column. So 5 times 2 is 10. And then I have an x squared, so 10x squared. Then I have the plus sign comes down. And this one has a 13 and a y left over. Yeah, it does have an x as well, good catch. Let me just rewrite it. There we go. If I wasn't using big old clunky pens rather than like a pencil, it's easier to see. This has an extra 3 and extra y squared. And it was a minus. So let me rewrite this below without all this scribbly shit. All right, so now I want to see if it factors further. I've got x squared, I've got an xy, and I've got a y squared. If I put something with an x in the front of 2 parentheses and something with a y at the end of both parentheses, these 2 will give me my y squared. These 2 will give me my x squared. And a combination of the outside ones and the inside ones will give me xy ones. So this might factor. One way of doing this, checking to see if it factors, is ignore the y for now and add it back in. So that's what I'm going to do, because it's a little easier to follow. Add back in. So I'm going to look at it as like this. I'm going to treat this as 10x squared plus 13x minus 3. And I know just whatever this factors into, I'm going to slap a y at the end of the last term. And we'll multiply it back out to verify. We can always verify. So this is trinomial factoring. I have a nice little table for this one too. This is the form ax squared plus bx plus c. So I can do a times c. This is a variant of the diamond method. But the diamond method requires you to figure out what the hell the factors are straight to it. This is a systematic approach to finding it. 10 times -3 is -30. and B is positive 13. So we're gonna stop and do a little critical thinking. If we need two numbers that multiply to A times C. And they need to add to B. So they multiply to A times C, add to B. If two numbers multiply and end up with a negative outcome, what does it tell us about the two numbers? One's negative, one's positive. If we add them together and we end up with a positive outcome, does that give us more information about the negative and the positive number? What?
Means the negative number is smaller.
Right, or the positive number is the bigger one, because that way, when we combine them, we gotta end up with a positive value. So what I'm gonna do is I'm just gonna start with the two factors that are the given ones. With that pattern in mind, the big number is the positive one. And I am literally gonna go down the table, and as this goes down, I am going to just keep decrementing or decreasing by 1. And then I'm gonna see if there's a factor that goes with it. So if I divide 30 by -2, I get 15. And if I divide 30 by -3, I get 10. -4 doesn't go evenly into this, so I'm gonna cross off the -4. It's no bueno, it doesn't help. -5 goes into it as 6. And -6 goes into it as 5. And now we've gone to the point where the positive number is not bigger than the negative number. So that's off the table too. And that means anything following this pattern is also off the table, past that. So now, add them up. -1 plus 30 is 29. -2 plus 15 is 13. Which is what we're looking for. But I want to go a little further and point out something to you. -3 plus 10 is 7. -5 plus 6 is 1. And if we did the -6 and the 5, that would have been -1. Because when you don't know what the factors are and there's big numbers, you can do this table thing. And you can guess and check around it, and it can help narrow it down for you. Notice I followed a pattern in doing these numbers. Do these numbers over here follow a pattern? A basic one, they keep going down. So they keep getting smaller. Which means if you've got like 20 different fucking combinations that you can factor, but you do them in this order thing, you can start skipping multiple stages, like go to like start with -1 and whatever the number is, and then jump down like maybe -5 and then -10, and eventually you like if I did 29 and I did 7 and I skipped this one, the -2 and the 15, I can see that the one I want has to be between 29 and 7, so it's got to be between -1 and -3. Does that make sense? So if I skip, like if I skip down to -5, there's a whole lot of skipping going on. I know it's either got to be -2, -3, or -4. But when you've got 20 on the list, jumping 3 or 4 at a time, you really narrow it down really, really quickly. Whereas guessing and checking can take for fucking ever, and you may not ever catch it. The other thing about this little chart thing is if you end up skipping the number, like if B was say 12, it means it doesn't factor any further. So doing this consistent order will show you if it doesn't factor further. I did an example in the Math 335, so check out that video if you want to see a little bit more. But we have -2 and 15. So the 10x squared, this goes down to, these stay the same, and we're gonna break the 13x into these two numbers. -2x plus 15x. It actually turns into a grouping scenario. When you get to here, the idea is group them in pairs. And do the greatest common factor. These two have a 2x in common. And if I factor out the 2x, I have 5x minus 1. These have a 3 in common. And if I factor out the 3, I have a 5x minus 1 if I make that a positive 3. Slow down, make sure everyone's with me. So like 13x, if I combine -2x and 15x, I still get the 13x. So these two add the 13x. That's what was going on there. I think I just helped someone catch up. Because I didn't point, I normally do arrows and point to it. My bad. Now we do these factoring these little things. They both have a 5x minus 1 in it, so we can pull out a 5x minus 1. And whatever's left over gets its own parentheses, 2x plus 3. And my slacker ass, I probably should have had, oh, don't forget, we got to put the y in at the end. I almost forgot the fucking y. So we're going to put this all together in one thing. I'm going to bring that 3xy squared. I'm copying that line down here. This factors into 3xy squared times 5x minus y times 2x plus 3y. And if I wanted to verify, I wanted to check my work, we can multiply all this shit out again. So without the y, it would have just been 5x minus 1 and 2x plus 3. It's a pain in the ass though. I'm going to put the 1 there so you can kind of see it, even though we don't really need it. If we were to multiply this out, let's just make sure we get this ugly parentheses. Let's multiply this out. So I've got 5x times 2x is 10x squared. 5x times 3y is 15xy. Negative y times 2x is negative 2xy. And negative y times 3y is negative 3y squared. And I do get what's in that parentheses. So you find the two numbers that are in common or that multiply to make a times c and add to b. We split the middle term up into that. We do some grouping. And I think I kind of like rush that. I'm going to rewrite this step right here down. Because I didn't have a lot of room on that page. So that was a previous step. This is now one big term. And this is now one big term. And we're kind of looking for like, what's the greatest common factor between these two? And the greatest common factor between these two is the 5x minus 1. So that's what we put outside. What's left over gets its own parentheses. If you multiply that back out, you will see you get this line right here. You multiply it out, you'll see that you get this line right here. Different order. I got the 15x and the negative 2x in a different spot. But they add together to get us the 13. And then the tricky part is the y. I saw that it followed a pattern where I could do like an x times a y. What you're looking for here, if it does this, the first one's got a squared letter. The last one's got a different squared letter. And the one in the middle has one of each letter, but not squared. If that's the scenario, if that's what's going on, that's where you can pull off this magic shit. All right, let's take a 5-minute break. I still got a little bit more to do in R4. I want to do an example with cubes and stuff, and then we'll get through as much of R5 as we can today. So what we don't finish in R5 today, we will finish on Thursday, and then we're going to do all of R6. And then I am going to make a video for R7 and 9.1. I added a week extension for the homework that was due this week because we didn't cover the material yet. And I'm going to do the same thing with the next week one because I'm making a lengthy video, and you got to have. It's just I'm trying to pack too much shit in too short of a period of time. But I do want us to get it caught up. Maybe I'll pause this video. All right, let's try something else that incorporates some of these other ideas. Let's do x to the 5th minus 4x cubed minus 8x squared plus 32. That list is pretty consistent. We need to look for a greatest common factor first. But the x to the 5th has a coefficient of 1, and the 32 has no x's. So there's no x in the greatest common factor, and the biggest number that can be in the greatest common factor is a 1. So 1 is the greatest common factor. We're not nothing to do with a 1. So no GCF. Then we count the terms, and there are 4 terms. So we are going to do the terms by grouping. Try the first and second one together, and then third and fourth together. And if that doesn't work, sometimes you can do first and third, and second and fourth. Usually, if one works, they both work. But sometimes it's a little bit easier to see the third and the first and third. Well, this is the first term and the second term, so I'm going to do those two together. And I'm going to do these two together. There is no coefficient that's in the GCF, and the lowest exponent is x cubed. So that's the GCF of the first group. I need an x squared minus 4 here for that. And ideally, I want another x squared minus 4. So I want to be able to factor out something here and have like an x squared. And the thing I wanna factor out is, well, -8, I gotta get rid of the -8. The negative's gotta go with it too. So if I take a -8 out of 32. 32 divided by -8 is -4. Which is good because the grouping worked. These can get pulled out. And it leaves behind x cubed minus 8. If the thing in front, the variable has an exponent, you need to check to see if it factors further. If it doesn't have an exponent, like 2x plus 1, it doesn't factor further. But we've got an x squared and x cubed, so we've got to see if these factor further. These fall under the two-term thing. X squared and 4 are two different terms. And x cubed and 8 are two different terms. It looks like we have a difference of squares and a difference of cubes. Because I can write this as x squared minus 2 squared. And I can write this as x cubed minus 2 cubed. So a squared minus b squared is a minus b and a plus b. A cubed minus b cubed is a minus b. And then we have a squared plus ab plus b squared. Which means if we follow this formula here for this one right here, A is x and B is 2. So I'm going to have, following that parentheses pattern, x minus 2 and x plus 2. And the same pattern holds here, the same thing as this. A is x and B is 2 here. So I'm going to have a minus b is x minus 2. And then I got this thing right here. A squared is x squared. Plus ab is plus x times 2 or plus 2x. And plus b squared is 4. This condenses down a little bit cleaner. I've got 2x minus 2, so I can write this as x minus 2 squared. X plus 2. X squared plus 2x plus 4. And if you take the time to multiply that all back out, we should get that. If you find yourself on the test getting done and you've got a half hour extra and you haven't checked any of your work, you should probably not get up and leave a half hour early, but actually maybe put your head down for 5 minutes, clear your brain. Like think about, hum your favorite song in your head, then go back and look over the test and do checks where you can. In this case, it would be multiplying it out and seeing that we get the initial. Okay, you guys ready for more? We're gonna do more with factoring in R5, yeah, 5 in a second. So we're gonna jump to the last topic in the polynomial section. Wait, I see pins still moving, so everyone's not ready. I will slow my shit down. You move seats, you're fucking with me. You're allowed to move seats, there's nothing wrong with it. Alright. Onward. We looked at combining them, we looked at factoring them. What about in equations? We have something called the zero product rule. Product is the outcome of multiplication. Which means the outcome is 0. The rule is if A times B equals 0, then A equals 0 or B equals 0. Simple premise. It's what we use to solve a lot of quadratic equations. Solve a lot of equations this way. Example 1. X squared minus 5x equals 6. Like, I don't see a 0 anywhere. Why is this following the zero product rule? Well, we're gonna make it have a 0. We're gonna subtract the 6 over and make this x squared minus 5x minus 6 equals 0. Then if you factor it, you should have x minus 3 and x minus 2 equals 0. This is very much like my A times B equals 0. Where that's A and this is B.
Six plus.
You're right, I factored wrong. Fail. Let's try this. If I had multiplied that back out, I would have seen that I done fucked up. And I did not check my work. I just raced through it. Don't do that. It's a good learning mistake. So if I did some shit like that on the test, I would have continued and had the wrong answer. And if I had time, which I would have gone back through and checked my shit. There's an easier way to check equations. Just plug in the answer. Yeah.
Isn't it still wrong? That would be -5 in the end, no?
-6 times 1 is -6.
Oh,
You multiply that out. Yeah, you get back to this. All right, so this means we can set x minus 6 equals 0 or x plus 1 equals 0. And we solve for x. Now we're back to shit we did the other day. X equals 6 or x equals -1. And you can always check your shit in the equation. -36 minus 30 does equal 6. And I'll check the -1. -1 squared is +1, and -5 times -1 is +5. These both check off. So they're valid. If you do check your work, when you check your work, do it in the original. Not one step in. If I had done x minus 3, x minus 2, and I said x equals 3 and x equals 2. I might have tried to check them there. And it would have done fucked up. I could have fucked up here. I could have had x squared minus 5x plus 6 and done this moving wrong. And I would have had different answers. So if I'd done that wrong and plugged it in even here, it would not work in here, but it would work in here. So like always go to the original line when you're checking over. Oh, we have a button? I saw you go like this. And then it looked like you went like that. And you were doing, she just put her hand down. I'm like, oh, hell no.
No, we're good.
That's a fucking Caesar's like, execute that motherfucker. All right, next one. The reason why I put one like here, this is because this is a common mistake even from end game math and physics and engineering students. The correct approach is to subtract the 16z over. And we get z squared minus 16z equals 0. If we look for greatest common factor, we get z. And so, and then I've seen students get stuck here. They get this one pretty quick. What about this one? If I set that equal to 0, just because it doesn't have a plus or a minus in it, it just means it's already done. Z equals 0 is an answer. We add 16. We get z equals 0 or z equals 16. My z's have a crossbar because if they don't, they look like 2's. This is the correct approach. Do not do this. Well, if we divide both sides by z, it's a valid operation. Well, you would think it's a valid operation. Z squared divided by z is z, and 16z divided by z is 16. Notice I don't get the z equals 0. And I actually made an erroneous assumption. We can't divide by 0. And by dividing by z, I assumed z did not equal 0. Otherwise, I could not divide by it. So don't do it. If you don't know if z can equal 0 or not, or whatever the letter is, don't divide by it. First off, you don't get all the answers, and second of all, you're actually making a fundamental mistake that most students don't think about. Ready for the last one? Yeah, Davis.
Could you, in that situation, could you just straight up assume that 0 is correct because you have a z on both sides of the equation?
You could say z equals 0 and identify it. This actually produces it through an algorithm. If you said z equals 0 by inspection, that's how they do it. If they don't do any math, they would say z equals 0 by inspection. But if you're gonna pull some shit like that, it better be trivial and it better be right. Like 0 is generally like the only trivial one, maybe 1. 0 and 1 you could plug in pretty quickly and go. I can see if they work because plugging 1 anywhere just makes these go away. It leaves behind whatever's left behind. Plugging in 0 wipes out anything with that letter. Those are the only ones that are really easy to do by inspection. The more you do this, the more comfortable you do by getting other things by inspection. But like when you're in a class and you're retested on it, don't do it. In your job. I would say do it, but you're gonna do shit like this. You know how to do this shit. I really know how to do this shit. But did I fuck this up? Yeah. Wow. I went too quick. That's all it is. I went too quick. I saw something that I've seen familiar before. And just fucked it up. God damn, my throat keeps tickling. It's this weather. All right, last one. Well. Last one of this form. I put this up here because this is another common mistake. Zero product rule only works if the side is 0. I cannot say x minus 5 equals 52 or x plus 4 equals 52. So no x minus 5 equals 52 or x plus 4 equals 52. That is some bad juju. That's my word. So how we go about dealing with that is we multiply this out and then we move the 52 over. If you guys want to see more stuff on factoring and stuff like that, and don't want to dig through that entire. Or that full chapter of the textbook, I can link previous semester videos where I like spend like fucking 4 hours on factoring and. I have like 6 hours on radical exponents and shit. Like dealing with that shit, so you can watch like more workout examples rather than reading the textbook. Some people are visual and don't like reading. And I get it. Fucking I normally hate me some math textbooks. I love reading, I love math, but I don't love reading math. All right, so does this factor? Into what?
Negative or x equals -9, x plus 8. No, x minus 9 and x plus 8.
So if the b equals plus or minus 1, the factors are 1 apart. So 9 and 8 are 1 apart. Then you just gotta choose the right one to make positive or negative. And so we said each of these equal to 0. I get x equals 9 or x equals -8. And I'll just check one of them up top. You can check them both. 9 minus 5 times 9 plus 4. Does that equal 52? 4 times 13 does equal 52. That is a common thing for anyone over like the age of 30. People know those numbers because what is that from? What has 4 times 13 equals 52? A deck of cards. There's 52 cards. If I ask nowadays, some of you have never fucking seen a deck of cards. How many have not seen a deck of cards? Don't be ashamed, raise your hand. There's really? Everyone's seen one? Some of you are fucking embarrassed and are hiding it. Normally, like half the fucking students haven't seen it, they have no idea. I know because they do this in stats all the time. I use decks of cards and statistics all the time. And someone will eventually go, what the fuck is that? They've never played cards. They've grown up in a technological world and the solitaire is fucking boring.
I've been watching blackjack.
Yeah.
I love me some gambling. Oh,
Yeah.
alright. You want to see some examples of some word problems? I could spend the time doing it, or you could go through the textbook and he's got a couple good examples at the end of R5. Or end of R4. Let's take a look at R5. Oh shit, I was about to write on this fucking thing. There's no more paper there. Fuck. I'm glad I touched it with my finger. God damn. Where did I wear the gloves to? Like, you can see that I'm getting inked already. Fuck. I don't know, I'm fucking just, there we go. Fuck, my hands get inked. If I don't wear like little mini gloves, I'll get fucking ink everywhere. It's fucking pain in the ass. And when my hand touches it, I don't feel that it's not right. Feels a little different, but fingertips, it definitely feels wrong. Alright, enough of that. You don't give a shit about that. Rational expressions and equations. Rational expression has the word ratio. Ratio is like A over B. Or in our case, we're gonna have polynomial over polynomial. So polynomial division. Thank you. All right, so let's just start off. We're gonna do some simplifying. We're gonna have 18x squared y cubed over 30x cubed y squared. The most reliable way of doing this is to write out the prime factors. Prime factors don't have any other smaller factors. Factors are things that multiply together. So 18 is 2 times 9, but 9 factors, 9 gets down to 3 times 3. And you can do it with the x's if you want to. But I don't know that's essential. I'm going to do it as a reminder though. 30 is 5 times 6 or 5 times 2 times 3. So I factored out the top and the bottom. Anything that appears on top and bottom, we can cancel out in pairs. And we leave behind a 1. So I've got a 2 here and a 2 here. I can cancel those out. Even though I've got 2 3s on top, I've only got 1 3 on bottom, so I can only cancel one of those out. There's no more 3s on the bottom and there's no more 5s on the top, so those are done canceling. The X's can go out in pairs. And the Y's can go out in pairs. And technically, we're leaving a 1 behind with each one. Normally, I wouldn't really emphasize that too much, but I think it's important to know. I can't tell you how many times I've seen in calculus, or even better, like calculus 3 or something, where they like eliminate everything, like simplifying, and they just said it was 0. It leaves behind a 1. So if I clean that up, what I'm left with on top is 3y, and what I'm left with on bottom is 5x. If you don't go down all the way to the prime factorization, we could have done 3 times 6 and 5 times 6. X squared y cubed, x cubed y squared. And then you see the 6's go. Same idea. Sometimes if you don't go down all the way to the prime numbers, you may factor one of these, factor them in a way that didn't cancel where they should have. And then another way of, instead of doing this with all the x's in here, is subtract the exponents. So x2 over x3. This is the same thing as x to the 2 minus 3. Which would be x to the negative 1. Which is the same thing as 1 over x. So that's where we end up with an x on bottom. Yeah.
You said they leave ones behind, what do we do with them? Do we just ignore them or?
Well, when you multiply this all together, 1 times anything just kind of gets rid of the 1. You know, 1 times 1 times 1 times 1 times 1 times 1 times 1, it's still 1. And then times whatever you have left is you're just left with whatever you have left. You do the same thing with the y. Y cubed over y squared is y to the 3 minus 2. Which equals y to the first power, which means that's where y gets left on top. We kick it up a notch. We have 2x squared minus 18x. Oh, now we've got pluses and minuses. 6x squared minus 36x plus 54. And just for your knowledge, R4 was based on chapter 4. You can see a bunch of shit. R5, you can see a bunch of rational shit in chapter 5. So that's handy. You can see a lot more rational expression shit there. The idea here is do the same factoring thing and then try to cancel. So first off, we're going to look for a greatest common factor, top and bottom separately. On top, I can pull out a 2x, and I'm left with an x minus 9. On the bottom, I can't pull out any x's because the 54 doesn't have an x, but they're all divisible by 6, right? So I can pull out a 6, and this is x squared minus 6x plus 9. I know what I wanted to have. I didn't want to have this x here. Get rid of that x. That gets rid of that x and leaves it as x squared minus 9. I wrote the wrong down thing over here. Because then we want to factor further. So x squared minus 9 is a difference of squares. It turns into x minus 3 and x plus 3. And when you factor the bottom, 6 is 2 times 3. This ends up factoring into x minus 3 and x minus 3. Then we see what cancels. The 2 can go. And one of the x minus 3's can go. And I'm left with x plus 3 on top. And 3 times x minus 3 on bottom.
So we should not put the 3 into that, or no? Or should we?
What does that mean? Oh, distribute it?
Distribute.
You can do that. You could make this 3x minus 9. I don't know which one Alex is gonna take. This is the easiest, and it's in factored form. On a test, I would take the top one. If that's what you really want to know about. Right? Is ready for more? Are we still having fun?
That's good too.
In like a math 44 class, this is like 3 weeks worth of shit we've done today. You just take it a lot longer. That's why I said I've got hours of videos up on how to do this. For lower courses, and I'll link them. I'll link stuff on factoring. I'll make a little section on linked videos from previous semesters. If that's beneficial, if no one wants it, I won't do it, because that's just extra work. But if anyone, does anyone want old videos on doing some of this stuff more? I see one nod, so I'm gonna do it. All right. You're so excited you had to stand up. You got, is that a pee gas? You need to go to the bathroom?
No, I just have a crooked tailbone, it's sitting too long.
Are you sure it's not the pee gas? It's just so much fun to say pee gas to adults. All right. So let's kick it up a notch. And I'm gonna multiply this by another fraction. Fuck yeah. That's how we roll. So what we did before still holds, because when you multiply fractions, I can make this just one big fraction if I put these in parentheses. And now it's one big fraction. And now I gotta factor each component. So factor each one at a time. It might help you to label them. If you need room on your paper, label them one at a time and then just reassemble it later. So a x squared minus 25. That is a difference of squares. X minus 5, x plus 5. B, All it has is a greatest common factor of 3. C factors into. Let me write it all out. Factors into x minus 5 times x minus 5, or you can say x minus 5 squared. And D, that's already done. Doesn't factor. So putting it all back together again, I got A times B on top. C times D on bottom. X minus 5, x plus 5. I got a 3. I've got another x minus 5. That's A and B. C was x minus 5 squared. And D was x plus 5. Okay, so we cancel out what we can. This x minus 5 cancels out the square. Because this was x minus 5 times x minus 5. So we got rid of that one. And I'm just gonna go across the top and see if I find it on the bottom. X plus 5 appears here. Again, this leaves behind ones. 3 is not on bottom, and I have another x minus 5 over here. So all I have left on bottom is 1. And all I have left on top is 3. So that just simplifies down to 3. Wasn't that super fun? That's just like fucking take that shit home and fucking put it underneath a magnet on a fridge. That's some good shit right there. You're thinking about it, aren't you, James? All right, that's a reminder of how to multiply rational expressions, dividing rational expressions. The key to doing this one is leave the first one the same. And division turns into multiplication if we flip that fraction. So flip. Instead of dividing by a fraction, you can multiply it by the reciprocal. Fucking barking spiders in here. It's a true story. My wife gets so mad at me when I do it in a restaurant. And it don't matter if it's silent. She knows by the look on my face. I guess it makes face. Even if I don't, I like to lean and let it out. But I won't do it in a restaurant because I know that'll red flag her. But she still knows. I guess my face goes lax, like just like no expression for a little bit. Alright. So here, then we continue with what we're doing, just like we did in the last problem. So this upper left one factors into x plus 2 and x plus 2. X squared minus 1 is x minus 1 and x plus 1. X squared plus 5x plus 4 is x plus 4 and x plus 1. And x squared minus 4 is x minus 2 and x plus 2. If we cancel out shit in common, it looks like an x plus 2 cancels. And an x plus 1 cancels. And we're left with x plus 2 times x minus 1 over x plus 4 times x minus 2. And on the test, that would be the form I'm good with. You don't need to multiply it all back out. I don't know what ALEKS is going to want you to do. That drink must be fucking hella good. You had it every single day. It's phenomenal, isn't it? The blue, smooth raspberry or something like that? And pineapple. Must be
If you
good.
can have like sugary stuff, there's more flavors you can try. But it's like,
Oh, it's 0 sugar?
Yeah.
Nice.
the Red Bull is sugar free, so I think it had like less some calories, but.
Yeah, I'm diabetic, so I try to avoid sugar, but I gotta have my candy once in a while. But when I mean once in a while, every night at bedtime. I don't have like a whole candy bar. I'll have like a thing of Mike and Ike's and just have a couple of Mike and Ike's or some shit like that, small candies. I like sugar. Alright, onward. Adding rational expressions. So to add or subtract, we need a common denominator. And usually your best choice is to factor the denominator and see what we got. Even factor the top two, something might cancel beneficially and simplify it, but it doesn't here. So this is 2x plus 3 over x plus 2 and x plus 3 plus x minus 4 over x plus 3. So they both have an x plus 3 already. This one is missing an x plus 2. So the way we deal with that is we multiply by a fraction that has the same thing on top and bottom. And I'm going to put these in parentheses. So we got one big fraction now with x plus 2 and x plus 3 on bottom. I have my 2x plus 3 from the left. Whatever sign was there comes here. And then x minus 4 times x plus 2. You really should at this point. Multiply it all out, combine it together. And then factor it and see if anything cancels, because it might simplify. So let's do that. And it's tedious as fuck, but keep writing down shit you haven't dealt with. Don't just do like simple shit. I'm gonna multiply out this stuff right here. This is x squared minus 4x plus 2x minus 8. And when I simplify all that out, combining like terms on top, I have an x squared. I have a 2x. Another 2x is 4x, and minus 4x is 0x. That's handy. And I got a 3 minus 8 is minus 5. Which doesn't factor into nice full numbers. It technically does factor if you want to have radicals, but we're not going to do all that. So nothing simplifies here, and that's the final one. And it's 5 o'clock, so we will wrap up R5 and do R6 on Thursday. And I'll have a nice little pretty video for you for R7 and 9.1. Which is a little bit easier than today's and tomorrow, Thursday's lecture. Have a good day, Godspeed. The tutoring lab's open for another hour. I'll be on Zoom tonight at 8:15 and 9:15 if you've got questions. And you're like still working on it, you want to ask questions, hop on.
For sure.
Thanks.